So we have our stars, they're looking the right size, they're fitting into the constellations. The only thing is they're all the same color, which might sometimes like sort of seem that way from Earth, but they're really not. And especially when we're wanting to get a bit of an authentic look of our sky, we kind of want to add in a bit of color. And the beauty of the database that we're working with is that it does record the data. And I want to take a moment to have a look at exactly how this is done because I find it kind of fascinating. I've got here a little Wikipedia page about the color index. And this is essentially a number between negative 0.4 and 2. And what it essentially is when I've never really done this before. I've just sort of been reading about it a bit. What an astronomer would do is they would look through a telescope that has a color filter on it. Like, for example, where is it written here? Blue light filter. Okay, so you got a filter that will only sort of let through blue light, and you see how big that star is through that filter. And then, for example, you look through one with a green-yellow light that can see the green-yellow light of the star and see how big the star is through that filter. And then, with figuring out the difference between that, you can run it through this beautiful formula here and create the color index, which is kind of a direct translation of the temperature, apparently. So let's have a look at how we can convert that color index into a red, green, blue value. We'll go ahead and open up our code. Now we're going to do a similar thing as what we did with the magnitude, in that we're going to load this color index data from the database. So I'm going to go ahead and open up my star info class. I'm going to go into let's have a look at our HYG reference again. Just open this up, and our color index is number 16. So what I'm gonna do is I'm gonna add a new variable. This will be a float, public float color index, and this will be from index 16, I believe. Yeah, 16. Okay. So color index equals pass utility dot safe float pass lines 16. Okay, so now we have that color index. Let's go ahead and convert that into an RGB value. Okay, so how we're going to do this is we're going to say we're going to have another variable. This will be called float. This will be called color. This will be a public color called color. And this will equal, what we've got to do is we've got to create a color utility that knows how to convert a color index to a color. All right, so let's do that. We'll go into our utilities class, a utilities folder. I'm going to create a class called color utility.cs. This will be a public static class. Color utility. We will be using a dictionary, so I've got to go using system.collections.generic. Okay, so let's create a function here. This will be a public static color. Oh yeah, there's something else. Oh, we've got to use Unity Engine. Now, because we usually with colors, you want to really fine detail. I believe the default color in Unity is a value between 0 and 1, and it's a float, so it can be massive. But we're going to be a bit more granular. Like, we're going to be more specific. We're going to use a bytes, or like values between 0 and 255 for our colors. So how we do that is we're going to say public static color 32. So 32-bit format, which would be like 8, 16, 24, 32, RGB and alpha as well. All right, so this will be color 32, color index 2 RGB. Does that make sense? 2 RGB, that looks good. This will be a float we're passing in. All right, the first thing we want to do is we want to make sure that it is a value between negative 0.4 and 2. So float clamped CI, I would say CI clamped equals clamp mathf dot clamp color index between negative 0.4 and 2. Now we're going to do something interesting as well. All right, first of all, I'll show you how we're going to get this data. What we've got, I'm going to go ahead and copy and paste something in here. This is a reference sheet. Like, I believe there is some fancy way of using a formula to exactly determine the color. But this, I think this is a bit easier. This is just going to say it's got a value for every 0.1 value between negative 4 and 2. So negative 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, all the way up to 2. So what we need to do is we need to turn this float into a float that's between these values. Okay, so let's go ahead and do that. Let's say float, what do we call this? CI rounded equals, we're going to say mathf.round. We're going to say our float, our CI clamped. Now if we round the clamped value multiplied by 10, all right, so it would go like, so for example, if the value was negative 0.333, it would go from that to negative 3, and then we round that to the nearest integer, which will cut off the 0.333, and then we divide it by 10 again. Okay, and now we can say, let's just say color 32 col equals, we'll just say color 32 col, and we say color lookup dot try get value, and we're going to pass in our CI rounded, because this is a key value index. These are, all the keys are floats and the values are a color. Try get value, CI rounded out col, and then we just return col. This will give us a null reference error if we've made a mistake here. It should be fairly airtight. Okay, so now we go to star info, and we're going to say color equals color utility dot color index to RGB. We'll pass in color index, and now all of our star infos have a color. Now let's make sure that our color is being passed into our mesh. Now we may think, oh, beautiful, because meshes have something called a mesh.colors. For example, if I go into, go into asset generators, star mesh generator, I could say something like this, mesh.colors 32. Oh, well, that's perfect. That's exactly what we're working with. That's where we'd get into trouble, because we're going to be deploying this on iOS and Android, and different platforms have different levels of competency, I want to say, or like ability to work with mesh data. And at this point in time, there's no way I know of to pass colors into a mesh for Android. There may be a way, none that I'm aware of. So instead, I'm just going to say mesh.tangents, which happens to be a vector 4, which is the same amount of values as a color. Like red, green, blue, alpha. That's 4 values. So mesh.tangents can equal stars dot select for each star. Let's see, I'll make this look a bit neater. Stars dot select for each star. Select. We're going to use the stars new vector 4 with the stars colors. So we're going to convert the color to a vector 4. So we say s.color.r, s.color.g, s.color.b, s.color.a. All right. Dot to array. That easy. I'm going to go ahead and make this look a little bit neater. Color.rgb and alpha, and convert the entire bad boy to an array. All right. So now we have the colors being passed in as tangents. Let's go ahead and implement this in our star shader. I'm going to go ahead and open up our star magnitude shader. I realize now I'm getting in trouble for having two different shaders because I'll just, you know what? I'm going to delete the distance shader for now because it's just going to get messy if I keep trying to keep track of two different shaders. I'm going to rename this just to star shader. I know I've changed my name, but that's like change my decision, change my mind rather. But that's all right. Okay, Starchart. This is just going to be the star shader from now on. All right. Now we're going to pass in. We're going to have a float for. We can call this color, but we got to make sure that we give it the tangent tag. So we're almost like we're lying. We're saying, yeah, give me the tangent. Oh, then I'm going to use it like a color. It's just a way of getting data into the GPU. And we're going to need to pass it through the geometry shader into the fragment shader. So we'll have another float for color. Now that we have the color, it's fine to give it that color tag again. So we'll be a bit more accurate. And now pass it to the geometry shader, and then pass it from the geometry shader to the fragment shader. So this will be exactly the same line as this one up here. And now let's go ahead and make sure it's being passed through. So o.color equals v.color. All right, so that's being passed through the vertex shader. Let's make sure we're passing it through the geometry shader as well. This G2F, we say out.color equals equals in zero dot color. All right, and finally, our fragment shader. Instead of this made-up color or this cyan color, we can say return. Let's see. The alpha we still want, but we do want to bring in. We can say i.color.xyz or RGB rather. It's the same way of expressing it in Shaderland. Okay, we might lose reference to this shader. That's okay. So I'm gonna just put in star shader. All right, they're all red. What happened? Remember, we've just added a new field, which means that we're going to need to re-render everything or regenerate everything to get that information through. So I'm going to go ahead and press generate and instantiate. Give it a minute. something nice about watching a computer work. It's kind of like, oh, yes, now do that thing that would take me days and days to do. All right, and now we have our beautiful colors.